Welcome everyone to the part 3 of model building. So let's start today's lecture. The skills we will cover in this video are linear regression, and then we will see the working of linear regression, and in the last we will see the evaluation of linear regression. So what is actually a linear regression in R? Linear regression is a statistical method used for modeling the linear relationships between a dependent variable and one or more independent variables. Now, dependent variable is the one that we are about to predict, and independent variable are those that helps us in predicting the value or the class of dependent variable. Now, linear regression assumes a linear relationship between the variables and estimates the coefficients to predict the dependent variable. The result is a straight line, or you can say the regression line, that best fits the data points. Now, what are the advantages of linear regression? Linear regression is a well-established and widely used statistical method. Linear regression provides straightforward results that are easy to interpret. R provides a flexible platform for fitting linear regression models. R also provides a variety of validation techniques which can help assess the validity and robustness of the model. Once a linear regression model is fitted, it's easy to make predictions on new data using the predict function in R. Now it's time to see the disadvantages of linear regression. So linear regression is typically limited to continuous variables. Linear regression assumes that the errors have constant variance. It is limited to modeling linear relationships between variables. It also assumes that the errors are independent and identically distributed. There is a risk of overfitting as well, where the model fits the data too closely and does not generalize well to the new data. In the last, linear regression is typically limited to one dependent variable and may not be suitable for modeling multiple dependent variables. So let's see the steps to establish a linear regression, or how we can make it. First of all, load the data into RStudio and make sure it's in the correct format for analysis. Handle the missing values and outliers if essential. Use graphical techniques to visualize the relationship between the dependent and independent variables. You can do it by using or making a scatter plot. Then decide which independent variables will be included in the model. Use the lm function in R to fit a linear regression model to the data. Use the summary function to view the model summary. Or you can also use the validation techniques to assess the validity of the model. In the last, you can use the predict function to make predictions on new data using the fitted model. Now, there's an important note to consider. These are the general steps and may vary slightly depending on the specific problem and the data being analyzed. So what is the syntax for linear regression? Here is the syntax to create a simple linear regression model in R. Just use the lm keyword past the independent and dependent variable and then the dataset, where lm fits the linear regression to your model. Y is the dependent variable, X is the independent variable, and dataset is the name of your data frame. Now it's time to do some practice, so let's move to RStudio for a hands-on session. Well, first of all, I will set my working directory. And here I will say data size R. All right. Now you can see that the working directory has been set up. Let's read the CSV file in the ADV variable. I will say read.csv, and the name of the file is advertising.csv. And here I will say head ADV. You can see 4 columns in your dataset: TV, radio, newspaper, and sales. Now what I want to do is to predict the sales. That is a regression task. If I use only one variable for the prediction of sales, then it will be a linear regression. If I will use these 3 columns for predicting sales, then it will be called as multiple linear regression. So first of all, I will load the library ggplot2. All right. And here, let's say I want to make a plot and see the relation of these columns with the column of sales. So first of all, I will say ggplot, and here I will pass the dataset ADV, and then I will say aesthetic, and I will say take TV on x-axis and take sales on y-axis. All right, and here I will say geom point. All right, and I will do one more thing, which is by saying core, and inside this function I will say find the correlation between ADV variable of TV and ADV column of sales. Now, if the value of correlation is 1, then it means a high positive correlation. And if the value of correlation is 0, then it means there is no relation between these 2 variables. However, if the value is -1, that indicates a negative and strong correlation. Let's run it. You can see the points going upwards in this graph, which means that as the TV increase, the sales also increase. And the correlation value is 0.7. That means a positive and strong correlation. Now, similarly, I will also check some other variables. All right. And I will say take sales on x-axis and radio on y-axis. And I also find the correlation. Now, these 2 variables also have a positive and strong correlation. Similarly, I will find the correlation and see the scatter plot for the last variable of newspaper. All right. Oh, I forgot to do something here. I had to change this to radio and the last one to newspaper. All right. So for the last one, you can see that newspaper and sales does not have a very good correlation. And the correlation value is also 0.2. That indicates they don't have a good correlation. Now let's move towards the real agenda of today's session, which is to predict the sales using the linear regression. So I will say linear regression model, and inside this model, I will use the function of lm. All right. Here I will pass the independent variable, which is sales, and let's only use the variable or the column of TV for predicting sales. And I pass the data equals to ADV. All right. And here I say LR model. Now this is going to be my simple linear regression because I'm using one independent variable. Let's run it. So you can see the values here, coefficients and intercept. All right. Now let's put the linear regression line in this model. And here I say ggplot, and I pass the data frame adv and then a static function. And inside this function, the value of sales on x-axis and GV on y-axis plus GM point, and in the last GM smooth. And I pass the method parameter and the value of LM. All right. You can see the regression line between these two variables. And you can see that most of the points or observations are near to this point of line. Now, if I want to predict sales with the help of these three variables, then I will make a multiple linear regression model. All right, let's say LR model 2, and I want to use all of the independent variables. This has an intercept of 2.9, and you can see the difference in these two models. Now let's move forward. Let's do the comparison of the above two models that we have just created. Make a summary of LR model and make a summary of LR model 2. All right. So here are the summaries for both of the models. You can see the residuals that represents interquartile ranges. That represents the quantiles of the model. And here is the R-squared value, which is 0.6. All right. But you can notice that when you have used multiple variables for the prediction of sales column, like radio, TV, and newspaper, the R-squared value increased. It became 0.8. So if this value is close to 1, then it means that your model is good at prediction. 0.8 means that your model explains 80% of the observations or predictions. You can notice here that newspaper is not much significant variable for the prediction. Now we can also do something like doing predictions on the unseen data. Let's say I create a test data frame, and inside that data frame, I pass the values such as TV equals to 67 and radio equals to 40 and newspaper equals to 58. All right, and here I will use the predict function and store the prediction in prediction variable. I say take the LR model 2 for the prediction, and the new data for prediction is test df. All right, and here I say prediction. Now let's run it. You can see the sales predicted for these columns is 13.4. So this is the end of today's lecture. That is how you can use linear regression in general to do the regression task. Now let's get back to slides. So here's what we have learned today. We have learned about what is linear regression, what are the advantages and disadvantages, and what are the steps to establish a linear regression. And in the last, we have seen how to do the evaluation of linear regression. So here's a little homework for you. You can click on the dataset here and find the CSV file. Your task is to clean the data and build a linear regression model. And in the last, you have to do the evaluation of the linear regression model. Now, good luck. See you next time.